composite functions. Now, when you do composite functions, and when you're dividing two functions together, you end up with a fraction with a variable in the bottom. You're going to have a domain restriction, right? That domain restriction is that the denominator cannot have 0, because you can never divide by the number 0. So when we get to that, we'll look at that when we get to it. Okay, so number 5A, composite functions. You're always going to start with the innermost parentheses. I do not like this notation. This is the new notation for composite functions. This is the old and steady way, which is the one that I like. So I'm going to start with the innermost function, which is the g of 2. So I need to find the g of 2. And the g of 2 is going to equal 2 times my x is 2 minus 1. So the g of 2 is going to be 4 minus 1, which equals 3. Now, I am no longer going to use the f of g of 2. I am going to substitute in 3 for my g of 2. So now I have the f of 3. So now I have to find the f of 3. The f of 3 is going to equal 3 times my x, which is 3. So the f of 3 is 9. So that is my answer to the f of g of 2, equals 9. G. I have the g of the f of 3 for my composite function. Again, this is the new style of saying, symbolizing composite functions. It's the g of f of 3. I don't like it. I'm going to stick with the old and good. So I start with the innermost function, which is the f of 3. So I need to find the f of 3, which equals, well, let's see, I have 3 times x. Oh, we did this already up on the top one. So the f of 3 is going to equal 9. So I'm going to substitute in the f of 3 with the number 9. I have the g of 9, which equals 2 times x minus 1, and x equals 9. I get 18 minus 1, which equals 17. So the g of f of 3 equals 17. I took 18 minus 1. C. I have to find the f of negative 2. It's my composite function. I start with the innermost function, which is the f of negative 2. So I have to find the f of negative 2. And my f function is 3 times x, and my x is negative 2. 3 times negative 2 is negative 6. So the f of negative 2 is negative 6. So I have to find the f of negative 6. And again, my f function is 3 times x. And again, my x is -6. 3 times -6 is -18. So the f of -2 equals -18. Pretty easy, right? Easy peasy. Okay, D. I have g of -4. The innermost function is the g of -4, so I have to find the g of -4. Okay, the g function is 2 times x minus 1. Okay, my x is -4. So I get -8 minus 1, which equals -9. So my g of -4 is -9. So now I have to find the g of -9. My g function is 2 times x minus 1, and my x is -9. 2 times -9 is -18 minus 1, which is -19. So the g of -4 equals -19. Questions, comments, concerns? Okay, let's do some more funner stuff. Number 6, what? It's a composite. Open circle is a composite symbol. What we just did, composite function. Guess I have to find the domain of each function as well. Okay, the f of x, which is x squared. Do you see it? Do you see where the f of x equals and the g of x? Okay, so number 6, I have to take the f of x, which is x squared. I'm adding it, so I don't need parentheses. My g of x is x minus 3. Hey, there's nothing I can combine or anything, so that's my answer. Okay, number 7. The f of x, which is x squared. This time I'm subtracting, so I'm going to need to put parentheses around my g of x, which is x minus 3. Yep, I have to distribute the minus sign. So I get x squared minus x plus 3. Nothing to combine. I'm done. Number 8, I have the f of x, which is x squared. I'm going to multiply to the g of x, so I'm going to use parentheses. And the g of x is x minus 3. I have to distribute x squared times x. X squared minus 3 times, or x squared times minus 3. Nothing to combine. I'm done. X squared times x is x cubed. Because when I'm multiplying with the same base, I add the exponent. That's x to the first, right? If I was just combining them, I would not add exponents. And I really wouldn't combine them because they're unlike terms. Oh, domains here. All reals, no restrictions, no restrictions, no restrictions. Yes, it would be, and that's what I usually do. The f of x, number 9, the f of x, which is x squared, I'm going to divide it by the g of x, which is x minus 3. Can I reduce this? I don't see any way to reduce this. Okay, do I have any domain restrictions? Do I have any domain restrictions? I can't let the denominator be 0. So it's going to be all real numbers except whatever number that makes my denominator 0. So what can't x equal? Can't equal positive 3 because 3 minus 3 is 0. Okay. Number 10, we have a composite function. So we have to do the innermost function first, which is g of 1. So the g of 1 equals, what's my g function? X minus 3. My x is 1. So what is the g of 1? Negative 2. So I'm going to replace this with negative 2. So I need to do the f of negative 2. And the f function was x squared. Please use parentheses. Negative 2 times negative 2 is 4. Okay, so the f of g of 1 equals 4. Number 11, another composite function. I have the g of f of negative 5. Start with the innermost function first, which is the f of negative 5. And my f function was x squared. My x is negative 5. Negative 5 squared. 25. Huh? Which way? Okay, good. Okay, so my f of negative 5 is 25, which means I have to find the g of 25. My g function was x minus 3, and my x is 25. So 25 minus 3, 22, right? So the g of f of negative 5 equals 22. Yes, sir. I think there's toilet paper. I got toilet paper, that's it. Where are you? I should have aimed for his head. Okay, let's keep going. Number 12. What are they asking me to do in number 12? Anybody? Is that a multiplication sign or a composite sign? Multiplication. So they want us to take the f function, which is 3x plus 2, and multiply it to the g function, which is 5x minus 4, but they want us to substitute the x with a 5. Okay, a little confusing, but we can do this. Okay, 3 times 5. 15 plus 2. 17. 5 times 5 minus 4.
What was the 9?
And Martin, what's 21 times 17? 21 times 17.
7
What is it? I bet there's 357. Well, that was easy. Number 13. 13 is what kind of problem? That's right, a composite function. Start with the innermost function, which is g of 3. So we have to find the g of 3. My g function is 5 times x minus 4. My x is 3. So I get 5 times 3 is 15 minus 4 equals 11. So I'm going to replace the g of 3 with 11. Which means I have to find the f of 11. And my f function is 3 times x
35.
plus 2. Yes, so this is 33. Plug in 11 for x. I get 33 plus 2, which is 35. So the f of g of 3 is 35. And the last two. Find the f times g of 4. So again, my f of x is the absolute value of 2 times x minus 1, and our x is 4. Oh, guys, it's so important. Okay, so we're going to take that and multiply it to the g of 4. And the g is, I'm going to put this in parentheses, 5 times x minus 4. And again, my x is 4. Okay, here I get the absolute value of 8 minus 1, times 5 times 4 is 20 minus 4, 16. 8 minus 1 is 7 times 16, which equals 42. 7 plus 4 is 11. 112. Are you with me, kids? Huh? Yes, ma'am. Sure. And 14, oh, I did. Wow, this is all screwed up number-wise. That's okay. I'm going to do the next one. Okay, it's a composite function. So the first one I have to find is the innermost one, which is the g of negative 2. So I'm going to move the paper over first. Am I smart or what? Yeah, it's like an old dog. I can still be trained. I need to find the g of negative 2. See 5 times x minus 4. My x is negative 2. Let's see, I've got negative 10 minus 4 is negative 14. So this g of negative 2 is negative 14. So I have to find the f of negative 14. And my f function is the absolute value of 2 times x minus 1. Yep, negative 14. Let's see, that would equal the absolute value of negative 28 minus 1, which is negative 29, but then I have to take the absolute value, and I get positive 29. So the f of g of negative 2 equals 29. I can go over homework. What were you supposed to do? The first page? So you were supposed to do the first page. Oh, somebody walked out without paying for something.
Thanks, sir.
The f of 2 and add to it the g of 2. Well, since they gave me a number for x, I have to evaluate them and then add them together. So the f of 2, I have to find the f of 2, is n plus 2. So I just substituted 2 for n. So the f of 2 is going to be 4. So I have 4 for the f of 2. Then I need to find the g of 2, right? The g of 2. And that's going to be 3 times n minus 5. And my n is 2. So I have 6 minus 5 is 1. And add those together, I get 5. Well, it says so right there. And again, I'm doing the same thing in number 3. I'm adding the two functions together. But this time they didn't give me any numbers to evaluate. So I just used the algebraic expressions. So I'm going to take my g of n, which is negative n squared minus 3. And I'm going to add to it h of n, which is 3n plus 5. And the only two things I can combine is the negative 3 and the positive 5. I get negative n squared plus 3n plus 2. I'm adding them. I'm adding the two functions together. That's what it's telling me to do. Take g of n and add the h of n. Well, the g of n is negative n squared minus 3. Negative n squared minus 3. And it says add the h of n, which is 3n plus 5. 3n plus 5. I could. The only thing you're going to combine here is the negative 3 and the 5 because that's the only common term. The others you have to leave.
It's just combining.
It's just it's just combining like.
It looks complicated.
It looks like you're getting confused between evaluating and adding algebraic expressions. Do you see the difference between 2 and 4? Yeah, but you see the difference of what they're asking us. In number 2, they're asking us, well, not only do you have to take the h of x, but yes. Well, they also, they want us to, for the g of, well, you don't have a value for the x, so just leave x as x. You don't have anything, you don't have anything to substitute in for it, so you just got to leave it. Okay? Like the g of x is nothing more than this, and since you don't have a number for it, you just leave it.